Hello, everybody. My name is Sean Harrigan, and I also work at ECMWF, and I work mainly on forecast evaluation. So there are a range of support and evaluation and auxiliary layers available on the GloFAS web map viewer that give you additional information to help make better forecast decisions. These are mainly broken into two main categories: the corresponding layers under the evaluation and static layer tabs. Focusing on evaluation, there are now 3 layers available on hydrological model performance and forecast skill. The first evaluation layer summarizes the results from the hydrological model calibration based on the modified Klein-Gupta efficiency, or KG. So darker blue colors show stations with highest performance, while grey stations show lower KG that highlight to users that caution is required. And it's strongly recommended to explore the performance of the model results in more detail. And this can be done by clicking on individual stations. And here we'll use an example on the Hyderabad station on the Brahmaputra River in Bangladesh. So first we see some metadata about the station together with the performance summary statistics. There are 4 main plots available within each window. The first is a KG summary and decomposition into correlation, bias, variability errors, shown as a speedometer plot. In this example, you can see that the overall KG is high, a value of 0.72. And if you look at the decomposition, you can see that the overall correlation and variability is also extremely good. But the KG score is, however, degraded due to a positive bias in the hydrological model. This is very important information when using GloFAS for forecasts, as it shows the timing of the peaks is well captured, but there is a systematic bias. Because GloFAS flood thresholds are based on simulated time series, this bias will be accounted for. And if we look at the second plot, you can see the monthly distribution of observed and modeled discharge, and that helps diagnose whether GloFAS captures the seasonal water balance well, and in this example, it does a good job. The third plot we show has the observed and model time series that was used for the model calibration. And this helps users understand the hydrology of both the catchment and GloFAS's ability to reproduce it. So in more complex issues around peak flow timing or maybe artificial influences on the catchment can be detected from visual inspection of such a plot. And the final plot in this window shows the full available GloFAS river discharge reanalysis back to 1979, and also together shows the modeled flood thresholds that are used for the dynamic flood forecasts. And the next layer we will move to coming up is the forecast skill, also within the evaluation tab. So the full methodology details for generating the forecast skill are available on the GloFAS wiki, but in summary, we use a large set of reforecasts run for very many dates in the past. In this case, we use the ECMWF 20-year reforecasts run from 1999 until 2018 with twice weekly start dates, 11 ensemble members, and run from lead times from 1 to 30 days ahead. So that's over 2,000 forecasts used to generate these summary statistics. We use the industry standard continuous ranked probability skill score, or CRPSS, as our headline forecast skill score. The precise headline score definition is given in the wiki, but also summarized in the legend here as well. And in summary, we look at the maximum lead time out to when GloFAS river discharge is skillful out to a value of 0.5. And this is useful to highlight to users which areas have the highest GloFAS skill and which have the lower skill and perhaps needs more information and more understanding. And so users are very encouraged to look at individual stations similar to the last layer by clicking in on the individual points. So when we look at the Popup graph, we see the first one summarizes the continuous rank probability skill score on the y-axis against the full 30-day lead time on the x-axis. Because GloFAS forecast lead time ranges from short, medium, and into the extended range, there's no perfect benchmark forecast for that entire range. So instead, we use simple persistence, which is shown usually better for shorter lead times. It's in blue, but we also include climatology as a benchmark in the red line for longer lead times. We also highlight in this graph at which point does the lead time drop below our high skill threshold of 0.5, and in this case, it's out to 2 weeks. And on the second plot, we, from user feedback, have included the individual CRPS components from that's based on native units now. It's a meter cube per second with the best CRPS value of 0. And this plot helps interpret the pattern seen in the above CRPSS graph and is used for more advanced diagnostics. There's a range of supporting static layers available to aid forecasters. These include, under the static layer tab, these include some geographic layers such as major river basins and administrative units, regions, but we also focus on upstream area and reservoir related layers in this demonstration. So a really useful layer when making a forecast is to look at the upstream area of the model. So here in GloFAS, we use any river pixel with an upstream area greater than 1,000 kilometers squared is colored with darker blue color showing larger areas. So this really helps understand the spatial resolution of the model and how well GloFAS kind of interprets the river system and the terrain of that area. This can be useful for making forecasts and understanding if you're making a forecast on a main river channel versus a tributary and where rivers, lakes and reservoirs might be located. In terms of lakes and reservoirs, we have the locations of the world's largest reservoirs and lakes are included within the model and shown in the GloFAS lakes and reservoirs layer. To get an estimate of the potential impact of the major reservoirs on streamflow, we have the reservoir impact layer. And this can be used, so in this example in the Ganges-Brahmaputra Meghna River Basin, this looks at the ratio of observed reservoir volume to annual streamflow, with darker colors highlighting reservoirs that potentially have large impact on streamflow. And so this can add an additional uncertainty to the forecast that's worth communicating to users and to users of that forecast. Whereas lighter gray areas show where the size of the reservoir has potentially much less impact and so is less of a problem. And so that is a quick summary of some of the valuation and static layers available on the GloFAS web interface. They hope to supplement your forecasts and add more information. So thank you very much.